Hey everyone, gonna finish off 8.4 notes, page 5, unit vectors. What's a unit vector? Okay, so a unit vector is a vector that has a magnitude of 1. And there's two special ones that are like horizontal and vertical. The horizontal one we'll call the vector I. Notice the components there are 1, 0 because it ends at the point 1, 0. Right? So that's that little guy right there. Right? And then the j is the vertical one, ends at the point 0, 1. So that's the vector 0, 1. Okay, so it turns out any vector can be written as a combination of those two little vectors. Okay, and the way you write that is a times the I and b times the j. So for example, write the vector 3, -4 in that ai plus bj form. Okay, so we can do that by, let's blow it up here. The first thing I'm going to do, I'm going to break this out into two vectors. I'm going to write this as 3, 0 added to 0, -4, right? Using my vector addition kind of in reverse, right? Notice if I added those two together, I would get 3, -4, okay? And then I'm going to use scalar multiplication, almost like factoring out the 3 here. But right, the 3 as a scalar, then that would be a 1, 0, right? Reverse distribution. Okay, and then I can take the 4 out, and I'd have 0, 1. And then notice what you've got there. The 1, 0 is I, and the 0, 1 is j. And there's your form. Okay. So you can almost see how it jumps right to that form, right? You just put the 3 where the A is and the -4 where the B is. But I did it sort of the long way, so you see why that's true. That's a pretty cool form. And so you'll see that form pop up as well. And then you'll have some problems like given these things, find whatever. It's complete algebra here. It's like basic algebra, basic, right? So these are kind of fun to do. Right? So I just replace u with 3i plus 7j and then distribute like algebra, right? The -3. That's -9i minus 21j. And that's it. The worst thing you can do on these is try to overcomplicate them. If you're asking yourself, is that it? Yeah, that's it. That's all you got to do, right? So it should feel like you want to do more or something, right? But that's it. Just do the simple algebra and you're done. So this one, I can do it. Plugging in the u is 3i plus 7j, right, plus 3. I'm just following that structure there. Plug in the v, -2i plus 3j, right there. I'm using that v, right? Distribute. Right. Minus 6i plus 9j, and then combine like terms. Ooh, 6i and minus 6i kind of cancel each other out. So I'm just left with the j's. 14 plus 9, 23. 23j. Okay. Okay. Let's try one more. I think you get the point here. The v is -2i plus 3j minus 4 times, and then the u, what was the u again? 3i plus 7j. Okay. To distribute that 4, that's going to be a minus 12i minus 28j, and then combine like terms. The i's would be a minus 14i, and the j's minus 25j. Okay, and that's it. All right, so let's do one more thing, which is called the dot product. And then we'll get into an application of it, because at first it's like, why would we ever do that? But there is a specific application. Okay, so the dot product, it's kind of like multiplying vectors, but turns out you don't like, well, it turns out the dot product is a real number. It's not a vector, right? So that's kind of the weird thing. right? And here's your formula, right? So when you take the dot product of two vectors, you actually just get a single number, right? I'll show you an example here. So number 9, I'm going to take -2, 1, and multiply it by 4, 3. And if I follow the rule here, it says take the A and the C, multiply together. So in other words, the two horizontal components, -2 times 4, multiply those together. And then add to that the vertical components multiplied together, 1 times 3, the B and the D, right? And then so I multiply the -2 and 4, that's -8. 1 times 3 is 3. -8 plus 3 is -5. Okay. And that is the answer. All right. Well, you might be asking, what does that mean? Nothing yet. We'll get to maybe where we could apply that. But right now we're just practicing finding that dot product. Kind of weird because you feel like you're multiplying two vectors together and getting a non-vector, but yeah, just go with it for now. How about A dot B? So I'm going to take, I can just do the 6 times the 10, right? So 6 times -10, and then add to that the 5 times the 12. Right? So that's going to be a -60 plus 60, which results in 0. So the dot product is 0. Okay. Okay, so the finding it's not too bad, and then applying it, here's where it pops up. It's if you want to find the angle between two vectors, here's a formula for that, and notice what's in the numerator of that formula is the dot product. Okay, so using dot product is a way to get to finding the angle between two vectors, and the angle is always between 0 and 180, right? Okay, so find the angle between those vectors. We've already found the dot product, right? So in number 9, there it is, we have that dot product. So I already know u dot v is -5, okay? In my formula, the next thing is I want to find the magnitude of u. So let's just find all the pieces first. So the magnitude of u, square root, right? -2 squared, going back to that magnitude formula from the first page, basically Pythagorean theorem, right? And that's going to be the square root of 4 plus 1, 5. Right? And then I need the magnitude of v, square root of 4 squared plus 3 squared. Right? That's 16 plus 9, 25, square root of 25, which actually just equals 5. Okay, so now I have all my pieces, and now I can plug them into the formula. Cosine of theta is going to equal the dot product, -5, over square root of 5 times 5. Right? Next, I want to find theta. So theta is going to be cosine inverse of that. And I guess I can cancel that 5 out. So this would just be -1 over square root of 5. Right? And you don't have to find reference angles or anything fancy on this one. Just plug it right in. And hope it's right. So this one I'm getting approximately, let's see, round to the nearest 10th, 116.6. That's my final answer there. Okay. Okay. Not bad. Could try another one. Find the angle between those two, and we did that. We found the dot product in number 10. Ooh, the dot product was 0 on that one. Okay, so if you find the dot product to be 0, so I already know that A dot B is 0, right? Then it doesn't even matter what the magnitudes of those are, right? In your formula here, who cares what the denominator is? The numerator is 0. The whole thing is going to be 0. 0 divided by anything is 0. So if I plug into my formula, cosine of theta is 0, right? And so that's going to be theta is cosine inverse of 0, right? And cosine inverse of 0 is 90 degrees. So these angles are at right angles to each other, right? Which leads to an interesting fact. Anytime that the dot product is 0, the angle between the vectors is 90 degrees. Right? Or if the dot product is 0, the vectors are perpendicular. Another word for perpendicular is orthogonal. So this is described here, right? Orthogonal vectors, if you get that the dot product is 0, then the vectors u and v are orthogonal or perpendicular or have a 90-degree angle between them. So the last type of question, are these two vectors orthogonal? Are they perpendicular? Is the angle between them 90? What you're going to do is the dot product and see if it's equal to 0. Okay, so I multiply the horizontal components, -1 times 1. That's those first two. Add to that, multiply the second to 1 times -1. Did we get 0 here? Let's see. We get -1 plus -1. Nope, that's -2. So no, they are not orthogonal. They are some other angle that we don't know. We could find it, but we're not going to because that's the end of the handout. Okay, hope all's well. That's 8.4. Woohoo. If you have anything, let me know. And I'll talk to you later. Bye.